There's grid. No. Show non-video participants. No. If I right click.
Well, what I'm seeing right now isn't too terrible. You see the screen up top, and then everybody's, like, icon, and the one person who's presenting's, like, camera. Um,
Yeah, so I see an infinite. Okay, yeah, like I can see your face down in the bottom, like you said, and then screen. Yeah. Yeah. Okay. Okay. I think we want to give it a few minutes to let people file in. Okay, I'll go ahead and get started. So, welcome to Louisville Makes Games Lightning Talks on this fine Sunday evening. Saturday evening, I should say.
I was about to say.
So, first, I want to give a quick spiel about what Louisville Makes Games is. Louisville Makes Games is a non-profit organization in Louisville, Kentucky, serving current and future game creators in the local area. And it maintains a co-working space called Warp Zone Louisville, and it runs events like this one. If you're here or if you're at our physical space, the Warp Zone, we have a code of conduct. So be sure to check that out and make sure you abide by it while you're on the Discord channel or in our Twitch channel or on the YouTube chat or in the physical space. So Louisville Makes Games and the Warp Zone host events like this one. We have public meetups twice a month that are available to anyone for free. They can come to this Discord channel to participate. In the near future, I think we're going to look at reopening our physical space for hosting those. The next event is on April 3rd from 2 to 3:30 p.m. Eastern Time. So we also host industry talks and game jams, workshops, and exhibitions. And so the overall goal of Louisville Makes Games and the Warp Zone is to help game creators in the city with their projects and with their career prospects in the industry. So that's us. Without further ado, I think we'll get started on the lightning talks. So first up is Prof.
Yeah.
Go ahead and share your screen. I would encourage people on the Discord channel to tune into her stream.
All right. There we go. Are we doing video or are we not doing video? Did we determine if that works or not? Should I show my amazing face?
By all means.
All right. Okay, so I'm going to get started here. So hey everyone. My name is Prof. I am a game designer, and I'm a Louisville, Kentucky native. And today I'm going to talk about unexpected game economies. So, when you think of a game economy, what do you typically think of? Maybe you think of experience points you get to level up characters, or maybe you think of currency that you get in a game used to buy stuff, or maybe you think of collecting crafting supplies and recipes that make up a crafting system. And probably you think of spreadsheets because that's what we tend to use to balance game economies. So, an extremely simplified metaphor for game economies is the faucet and drain model. Your game has some kind of currency, and you design ways that the currency is pumped into the game and ways the currency is removed from the game. So, let's look at a straightforward example. Let's look at a typical Zelda game. So, the currency in this game economy is rupees, which you collect. The faucets are how the rupees get into the world, where the player acquires them. This can be things like having them spawn in bushes or pots, or maybe get them as a reward for killing enemies, or winning them in a game of chance and such. The drains in this system are how we get the rupees out of the economy. Most obvious, of course, is shops. You spend rupees to buy items and upgrades, and the rupees are removed from the system. And there's other ways that you can get them out of the system, like, when a like attacks you and catches you and eats up all your rupees, that is a way of getting rupees out of the game economy. So in Zelda, or games like Zelda with some kind of monetary currency, you can balance the economy by adjusting the faucets and drains. Let's say your players end up with too much money and they've bought everything available in the game, but they're still overflowing with money. You could adjust the faucets to decrease the amount or the frequency that the player acquires money, or you could add more drains. You could increase costs, have other things to spend money on, etc. Here's another example of a game economy: NPC reputation systems. The currency in this model is reputation, and this can be thought of as goodwill towards NPCs or even romance if you're making like a dating sim. And what are the faucets for reputation? How did they get into the game? And a lot of games, it's stuff like performing quests for a particular faction gets you a certain amount of rep. And the drain can be something like killing or hurting a member of those factions loses you rep with them. Or maybe doing quests for a different faction can drain rep from another one. And you can do interesting things to adjust the faucets and drains here, like a quest for one faction that involves killing members from another, and so on. So those are some more typical game economies. However, we often have unexpected economies in our games that we don't think of as economies. So here's a few examples of game systems that you can think of in terms of economy. So some economies in your game have things that you want to drain as much as possible. And one of those is the idea of cognitive load. So cognitive load is something I'm particularly sensitive to because I have a cognitive disability. So it's something I think about a lot. The currency in this system is the amount of cognitive load that the player has to endure. The faucets are usually cognitively demanding systems. So maybe progress trees with multiple layers or multiple menus of decision making. Anytime you add complexity to your game, whether it's in tactics or execution or just decision making, you're introducing cognitive load into your game. And if you find you have too much, what are some ways you can get it out of your system? Sometimes that is looking for ways to simplify and condense some of your systems. Or perhaps you can have templates or presets as alternatives for heavy long-term decision making. Or introducing low complexity options. So let's say you have a character in your game that has a high skill level of execution, lots of complexity. Maybe introduce or include other characters that are lower power but simpler to use as a way of mitigating the economy of cognitive load in your game. Here's another interesting thing that can be looked at like an economy: novelty in your game. So the currency here is the sense of discovery and excitement your players have when encountering new things in your game. So we're treating player experience as the currency instead of something tangible in the game. Faucets for novelty are when you introduce unique content. So maybe you introduce a new enemy, and that can acquire that sense of discovery and excitement in your player. Drains for this are repetition. Like, it's cool the first time you see a new enemy, but by the 10th time you've run into it, we've depleted that resource, that sense of discovery that comes along with it. And amusingly, another drain for this resource is also unique content. So how is that? How can you have one thing be both a faucet and a drain? Well, in this case, it has to do with pacing. Introducing a cool new thing gains you player excitement, but then if you immediately introduce 3 more new cool things right in a row, it can have an adverse effect and drain the excitement from the other things before you've gotten your money's worth out of them, so to speak. All right, here's another system that we can look at as an economy: social gifting. This is, of course, very common in social games. And unlike the cognitive load example, this is an economy where you don't want to drain too rapidly. The currency being exchanged here is social capital. Social capital is built up through meaningful human interactions. And often when your players are entering your game world, they have some of this built up already. So it's interesting because the faucet here is bringing in something outside of the game. Social capital can be drained by things like a gifting system that you use for your own reward. So, like back in the day in social games, you could give gifts to your friends as a way of acquiring more stuff for you in the game. And it led to a bunch of spamming. And that sort of interaction reduces social capital. Similarly, if you have a social sharing system that's relatively shallow, this could be something like, posting your scores to something in a way that no one ever acknowledges. So it feels like you're putting this out there and no one is responding, and that can drain the social capital you have with your friends. So if players are bringing their source of social capital from outside the game, is there any way to add more faucets to this economy? Well, one way is providing opportunities for reciprocation in your game. This can be a way of increasing the social capital between your players as long as they feel genuine. And this is something you can do within your own game. All right, here's the last example. Let's look at the economy of your players' time. So the currency is, of course, the amount of time players can invest in your game. And the interesting thing about this economy is that there's a fixed amount coming in. You can't magically give people more time in their day. So the faucet only has as much as it can give. And the resource is simply drained by the time it takes to play your game, or actions per session if you want to break it down like that. So, what can you do in this case if you can't add new faucets? Well, there's some techniques you can do to slow the trickle of the faucet. It's not quite giving back time, but it does help. For example, idle progression options can help here. Idle games are built on this, the idea that the game can progress while you aren't playing. Or a type of currency exchange. And this is stuff like letting your players pay their way through time gates in your game. It's exchanging their time for something else, another resource that they have a lot of. So, many game systems can be looked at as economy models. And if you think your game doesn't have an economy, you're wrong. So, figure out what it is so you can balance it. Thank you for listening to my talk.
Okay, thank you, Prof. Next up is Colton.
Straight up laughed out loud at that. You're wrong.
Well, I just tell it like it is. You know what I'm saying?
Love it. Give me just a moment to get my stuff on the screen here. All right. Let me know if you could see my stream.
Sure can.
Fantastic. All right, here we go. All right. My talk is gaining XP as easy as 1, 2, 3, also known as tips and tricks for creating progression systems in video games by myself, Colton Ramos. Numbers alert, don't take any notes. I'll give you the slides at the end. So there's that. Who is this guy? My name is Colton Ramos. Hi. I am the owner of I Make It Games. I'm a nerd, a programmer, and a Unity lover. I'm half of the team currently working on a big indie action RPG project called Curse of Eternity for about 3 years now. And you can check it out at, plug yourself, steam.curseofeternity.com. You can also see pictured my wife and my 2 cats. What the heck is this talk about? I want the player to level up in my game. What sorts of things should I be considering if you've asked this question? This talk might be for you. So systems are good. Let's assume for a moment that we're making a game with some kind of progression system like an RPG or an idle game or etc. Do we have any way to know what tangible effect changing important numbers in our game will have before playtesting really even starts? Like the amount of money we need to build a new lemonade stand in our idle game, or the amount of XP we need to level up in our RPG, or etc. If the answer is no, then we probably need to take a step back and try to define our game's progression system. Defining the progression system in our game is an extremely powerful tool. It gives us explicit control over the difficulty curve at every point in our game. At first, saying that sounds cold and mathematical, but actually we get to make a lot of artful choices through math. Like, how quickly do we want things to get more difficult over time? And how long do we want the player to spend at every area in our game? And when we define our progression system well, we get to learn things about our game, even things like how many assets will our artist have to make for items of varying power levels in our game. And defining our progression system can be as shallow or in-depth as we want it to be. Different games and developers will have different needs. Having a well-defined progression system in place does not mean that you've got everything charted out to infinity. Although, yeah, you can chart things out to infinity. And it doesn't mean that you can't artfully tweak variables when playtesting. But having a well-defined progression system does mean that you have a better understanding of what changing global variables will do to the whole game, like how much health does the player get when leveling up, and you have a better understanding of what changing local variables will do to single encounters or items or etc., like how much damage should these super awesome rare katanas do. Before we start, real quick, as already mentioned, but some helpful tools when looking into defining your progression system would be tools like spreadsheets. You can check out Google Sheets, it's free, or Microsoft Excel if you're on Windows and have Office or something. And definitely check out using formulas in your spreadsheet software, because that'll be extremely powerful. And then a graphing calculator or Wolfram Alpha would be a great way for you to figure out what kind of functions you can use to get the intended results out of your systems. Okay, but where do we start? Defining our progression system is one of those problems that's best viewed with a top-down approach. Again, different games and developers will have different needs. So using that top-down approach, we had to ask big questions like, what does progressing even mean in our game? Like, does our monkey hero collect bananas and use those to level up? Or does the monkey hero collect their bananas from fallen enemies? Or do they collect bananas from completing quests? Or maybe the monkey has a banana farm and will collect bananas over time. We can start from the top with a small set of these answers to these big questions, these universal laws that have global trends that fit our game's theme and our game's intended gameplay. And we can design and build the system and try it out. We can add more rules to the system as the needs arise and build a more complicated, larger system instead of starting out with something so complicated and large. Because our systems aren't glued permanently in place. And when we figure out what those universal laws are and how gameplay takes place at a basic level, it should be easier, maybe not easy, but easier for us to pick out a critical metric or several critical metrics for our progression system. Critical metric meaning, as the player progresses through the game, what's the most important thing we need to look out for? And one of my favorites to consider when you're considering an RPG where there's a combat system is time to kill, or TTK. And here's an example that I kind of made up. On this chart, the y-axis is the time to kill in seconds, the number of seconds it takes for character A to defeat character B. And on the x-axis is delta power level, which is the difference in power level between two characters. So in our monkey RPG, we want characters of about the same power level, or 0 on the x-axis, to defeat each other in some nominal time. We could just pick something for the sake of creating our system and call it 10 seconds. So that might be a level 1 character attacking another level 1 character, or even a level 6 character attacking another level 6 character. In both cases, it would take about 10 seconds. However, what we want is for stronger characters to defeat weaker characters in less time. That's moving right on the x-axis. So a level 6 character may be attacking a level 1 character, moving left on the x-axis. A level 6 character attacking a level 1 character takes about 5 seconds to kill. And then the inverse is also true. A weaker character should defeat a stronger character in more time, moving right this time on the x-axis. A level 1 character attacking a level 6 character might take 15 seconds to kill. And after we've defined our critical metric, we can use this to help keep our system in check. You could even use time to kill to help define the amount of health or damage characters get from leveling up or from their weapon drops. Here is that same time to kill. I just wanted to play around and figure out how to work backwards to get that graph. So you can use something like a graphing calculator, use something like Wolfram Alpha, and just use Google to help find functions of various shapes and kinds until we figure out some function that'll give us a trend line that operates the way we want. Here the trend line turns out to be, and this is a simple example, y equals x plus 10. And now we know, given any two characters, we just put in their levels, subtract it, find that value on X, and we can determine how long it would take for any character to kill any other character, which is extremely helpful. So in this simple example of two characters and of different power levels, and we know how their combat will interact a little bit better, how should power level change as a function of gameplay? Like how much experience or souls or like money or whatever should the player need to level up and get stronger? If we take a look at a classic example, here's actually a chart of the XP to next level versus level from Dungeons and Dragons 5th edition. This is straight out of the player handbook. On the x-axis is the amount of experience that is each hop, each level up. So how to get from level 1 to level 2 and etc. And on the y-axis is just the number of experience. So on the bottom axis is levels and the y-axis is how much it takes to get to the next level. And there's some interesting properties here to look at. There's some things that they built into the system that make gameplay better. The first thing to notice is that as the levels increase, the space between levels grows as levels get bigger. So this means farming weaker enemies and encounters becomes less viable over time. Fighting stronger enemies at a lower level is more rewarding. Also notice here how Wizards of the Coast define their system. They didn't use a formula for it. I mean, maybe they started with one, but they definitely made tweaks to their system to put wider gaps between levels of more or less significance. You can see because the graph is kind of bumpy that they sort of chose these values because of a reason. And if you haven't played Paper D&D before, some class features and powerful new abilities are spaced out in regular intervals. So at level 1, 4, 6, 8, there may be more powerful things happening. So a level 11 is probably a really important level, for example. But note that D&D, how they defined everything as a list of the values, only goes to level 20. That's the highest level that you can achieve in bog standard 5th edition D&D. What if we wanted a system that scales out to infinity? Or what if my game doesn't do that thing where you grant specific feats at specific levels like 5e? Well, the curve is sort of based on this. Here's an example of a very similar looking curve you could tweak that would go up to infinity. And just to quickly break it down, this is a quadratic equation, and it's got 3 terms. The first term in green, 100, is the constant, and that is equivalent to the amount of experience required to level up at level 1. And you can increase and decrease that to taste. The second term in blue is the amount of additional linear experience required for each subsequent level up. So that'll define the global trend, how sloped the entire graph is. And it defines the amount of space between levels at every point in the graph. So it's kind of like making the hill steeper or shallower. And then the red term is the additional quadratic XP required for each subsequent level. So that gives the curve. It makes it look kind of like the edge of a ball. You can see as the levels get higher, they get higher faster. So increasing and decreasing this value makes leveling up at higher levels much more difficult if you increase it, or easier if you decrease it. I think I said that right. We could conceivably use a subsystem like this and work backwards to define how many bananas an enemy of a given level will drop, which I don't have time to go into. But you could. Okay, now that we know our critical metrics and how those things scale with characters of varying power levels, we can start to ask some really big questions about how the game will look overall. You can take the whole game, conceivably after you've decided how much content you want in the game. But you can look at the goal game and ask questions like, what are the weakest characters and challenges going to be? What about the strongest? What should our level cap actually be, given the amount of content we want to put in the game? What would it look like if the strongest character went back to fight the weakest, or even vice versa? And, well, what if the player goes off the beaten path and skips ahead to the next town? should they be powerful enough to compete with those enemies in the next town, or should they wipe the floor with the player and then the player has to go back to the starting zone? The answers to these questions will, of course, depend on the developer and the game. And these are those artistic choices I was talking about earlier. We can consider these thought experiments and use them to shape the global trends in our game systems at a higher or maybe a medium level. And then exceptions. What about those artful exceptions to our systems? How do those work? Basically, just try your best to leverage the system. If we just use our creativity while still utilizing the systems we've developed, then we could do our best to keep things like adhering to the good properties of those systems as best we can. Like, for example, if you want a glass cannon enemy that scales appropriately in your game, you could, for example, take nominal metrics for a character at a given power level through the systems you've developed and just like multiply their hit points and damage by some factors, like give them half the normal amount of hit points for that level and twice the amount of damage for that level. The for that level part's important because it keeps your system in check. And then, of course, testing can tell you how much you want to increase or decrease those artful things. But the examples here are endless. And basically, exceptions should be a rarity, not the rule when you're developing like a game. Like even the Wizards of the Coast, those guys started with systems and tweak them to taste. They didn't start with nothing and create a system out of nothing but exceptions. Players expect things to behave consistently with how they've seen things behave in other parts of the game. So to recap, defining the progression system in your game is an extremely powerful tool. It gives you more control and it informs artistic choices. You should definitely define your progression systems if you have them. And in order to do it, you should use helpful tools like spreadsheets and Wolfram Alpha, define universal laws and start at the top, pay attention to critical metrics, consider your overall power level scope of the whole game that you're making, and leverage the systems that you've worked so hard to create, and try to keep the exceptions to those systems minimal. Thank you for your time. Here are the slides I promised. You can talk to me through this email address or on this Twitter account.
Thanks a lot, Colton. Next up is Jonah.
All right, let me get things set up. Let me share camera. And I'm going to share my entire screen. I'm going to go to here into present. Pull something up. Alrighty, and are you able to see this first slide, everyone? Think it's going.
Sure can.
So, hi, my name is Jonas Agree. I go by Galactical Online. The title of my talk is How I Make Puzzle Games in 5 Minutes. And before you ask, I'm saying that it's going to take 5 minutes to explain how I make puzzle games. I don't make them in 5 minutes. Although, every game you see on the screen here was made over a short period of time, from a week to a weekend, or even a single day. People often ask me how I design a puzzle game from start to finish in such a short period of time. And to answer this question, I've broken down the process I use into 3 steps. First, I create a mechanic that I believe meets 3 criteria: that it's simple, novel, and raises questions. Once I've decided on a mechanic, I create a list of answers to those questions, the most interesting observations about the mechanic, and order those into a series of lessons to be taught to the player. Finally, I construct levels that allow players to naturally make these discoveries themselves through the assumption, twist, and revelation framework. So, one way that I evaluate if a mechanic meets these 3 criteria is through the GIF test. I ask myself, is my mechanic simple enough to understand, novel enough to gain the player's interest, and raising questions that grow that interest in under 8 seconds? I use this GIF from one of my games, Flip the Page, as an example. So, it's simple enough to understand what's going on. You're a stick man walking around a piece of paper, pushing pictures into place. It's novel enough to gain your interest. The idea of walking around both sides of a piece of paper is new, so much so that people might have to watch it a few times to understand what happened. And it raises questions about the details as a result. Questions like, how many ways can I flip an object around? What if I were to push a long line of objects around the page and back into my character? would my character push himself, or would the object stop him from moving? So these questions lead to the next step, which is to create a list of answers to those questions and observe the most interesting phenomena that results from your mechanic. Then order those into a series of lessons that progressively teach the player more about your mechanic. So here's an example list of the first 4 lessons in another of my games, At the Hedges of Time. So first, the player learns they can rewind time to fix their mistakes. Then they learn that if you push a crate onto a target, you open an exit. And then the purple crates do not rewind with you. So these observations are all part of the tutorial, and so they're given to the player fairly easily. The first, more subtle lesson the player's expected to discover on their own is number 4. You can rewind to end up inside a purple crate. So then the question is, how do I go about having the player make this discovery on their own in a satisfying way? I use the assumption, twist, and revelation framework. So I first heard about it from Mark Brown on Game Maker's Toolkit, and I find it a super useful way to create compelling puzzles quickly. First, you manipulate the player into making an assumption. It's important you don't trick the player by breaking the rules of your game. This will just leave them feeling cheated. You use this assumption to force them to try a false strategy and encounter the twist. Their initial assumption is going to fail, and the puzzle will appear to be impossible. I find that more compelling puzzles emerge from a single, simple twist rather than a series of convoluted steps, where the player doesn't know where to start. Then finally, the player has a revelation. This is where the player discovers the key insight about the mechanic, the observation we wrote down on the list, and then a way to use it to their advantage and overcome an obstacle that appeared impossible at first. So here's another example, how I use the assumption, twist, revelation framework, and this is for level 4 from At the Hedges of Time. I know when I first start making the level, the lesson the player needs to learn is observation 4. The player can rewind to stand inside of a purple crate. So first, the player makes an assumption that they must push the crate onto the target, then proceed to the exit. This is how the player is beaten the last 2 levels, so I take advantage of this assumption to force the player into the twist. The crate blocks the path to the exit, making the level appear impossible until the revelation. The player makes observation 4 from the list. You can rewind to end up inside a purple crate. Once the player knows this, they can find a way to use it to their advantage to beat the puzzle that seemed impossible. So here's how that works in this video. You can see the player walks on top of the place where the crate will eventually block, kind of recording their position, and then rewinds to that moment in order to pass through the crate. So to recap my process for making puzzle game, it begins with the mechanic. I imagine the game as an 8-second GIF to evaluate whether it's sufficiently simple, novel, and raising questions. I then create a list of answers to those questions, the most interesting observations about the mechanic, and order those into a series of lessons for the player. Then finally, I construct levels designed to let the player discover these observations for themselves through the assumption, twist, and revelation framework. There's a lot more I could say, but just like how you can't make a puzzle game in 5 minutes, you can't explain how to make one in 5 minutes. But I hope you're able to take away something useful from my process. Thank you.
Thank you, Jonah. Next up is Alex.
Alrighty, let me get some here. Turn on camera. Discord not recognize my camera. I guess Discord doesn't want me on camera today. Let me get slides pulled up from beginning and share screen. All right, so hello, I'm Alex Garbus, and I've been doing a lot of toying around with Godot lately and wanted to give a talk kind of introducing people to the concepts of nodes and scenes in Godot, which serves as the foundation for how games are made in the engine. So Godot, for those that don't know, is a free open source game engine that supports 2D, 3D, and augmented/virtual reality. And as I mentioned, games in it are created using nodes and scenes. Here's a look at what the editor looks like. Now, nodes are the basic building blocks of your games in Godot. Each one is responsible for various behaviors. This is the player from the game Dodge the Creeps, which is a tutorial project for Godot. And we've got 4 nodes that make up the player, each responsible for its own behavior. The one labeled player is an area node, which it defines this area where it's responsible for detecting collisions and bodies and other areas. And then we have the animated sprite, which is the animated sprite node, which is responsible for displaying and animating a sprite on the screen. The collision shape 2D node, which defines the shape of the area, whether it's a capsule or a rectangle, etc. And the trail node, which renders a trail behind the player when they move. Nodes can have other nodes as parents and children. You can kind of see the nesting here. The player is a parent. The player area node is a parent to all of these child nodes. And you can also have scripts attached to nodes to extend their functionality. In this case, the player, you can sort of see this icon that looks like a piece of paper. That indicates that there's a script attached. In this instance, the script makes it so that the player can move when keys are input. Now, scenes are a tree of nodes, where one node acts as the root. So in that example we just saw with the player, that area node, what is the root of the scene. So, and then these scenes can then be instanced into other scenes. So the main scene, since this is a one-screen game, it has the player instanced into it, and the player is made up so the main scene is a tree, and then it has the player, which is its own tree. Then there's the scene tree, which is the tree of all scenes active at runtime. A main scene is selected to load when the game is first run, and the active scene can be changed at any time via script. So in this Dodge the Creeps example, because it's just a simple one-screen game, it just has this main scene that gets loaded at runtime and has all the nodes that make your game work. So essentially, your game exists as a tree of nodes. Final concept that I wanted to touch upon here is autoloads. These are scenes that are always loaded outside of the scene tree's active scene, and they are globally accessible via script. So in this example, we have the main scene, which is scene A. You can see it's a tree of nodes, and then we have the global node. This is the autoload, and this is always part of the scene tree. Even when scene A changes to scene B, global will still be there. If you're familiar with the singleton design pattern, which is where you have one instance of an object that's globally accessible, that's how this is implemented in Godot. And that's all I've got.
Okay, thanks a lot, Alex. Next up is me, so I will start by sharing my screen. Okay, let's see. Okay, can you all see my screen?
Mm-hmm.
Okay, so Jonas said that it's not possible to make a game in 5 minutes. Hopefully I'm going to test that theory. My talk is a Playdate with Playdate. Making a game for Playdate in hopefully 5 minutes. So Playdate is a console from a company called Panic. It's a handheld game console with a crank, and it is this very stylish, sleek, yellow little toy with a black and white screen, and so all the games are 1-bit. And it's very easy to make games for. It uses a programming language called Lua. So I'm going to share my other screen and show you how to do that. Okay, let me know if you can see the Windows environment here.
All good. We can see it.
Okay, if we go to the Playdate website and click on Dev up here, the SDK is publicly available for this console. So all we have to do is agree to the terms and download it. And once it's downloaded, you can install it like any other Windows program. You want to pay special attention to where you put it though, because for complex Playdate games, you're going to want to reference the standard libraries that come with the SDK. I'm just installing it at the root of C. Once it's installed, part of the SDK is a simulator, which lets you develop your game and run it on a computerized simulation of the Playdate console. And so we'll come back to this here in a bit. When you install it, you want to make sure, this is outlined in the documentation, but I'm going to show it to you here. You want to go to your environment variables, go to path, and go to edit, and add your path to the Playdate SDK to your environment variables in Windows. You can do the same sort of procedure in Linux or Mac. The instructions are a little different for that. So, how do we make a game for this thing? First, we need a folder to put our game stuff in. So, the folder should really be structured like this. The folder itself with a source folder inside of it, and in the source folder you put everything. So I maybe cheated a little bit and made some art assets ahead of time. So I'm going to drag those in. And we start with a main.lua file. So I'm going to open up a code editor. Visual Studio Code is good enough. And let's go here. New file. Save. Go to my game. Source. And it's going to be a Lua file. Called main.lua. Okay. So I'm going to just create some quick shortcuts for referencing some of the libraries built into the SDK. That should save time. Let's see. Okay. So let me maximize this, and yeah. I'm going to create a function called load. This is basically the first function that's going to run when you start your Playdate game. do playdate dot start accelerometer. The Playdate has a built-in accelerometer that is off by default to conserve battery life. So I'm going to turn it on just to demonstrate that feature of the console. We need a player and an enemy. So I'm just going to make those in love.load. They're just going to be simple Lua tables. And each the player needs an X position and a Y position. So X, Y, and then that player image I drug in earlier, we're gonna add that here. So I'll just put the X position to some random position. And then the Y position, let's see. Let's make it at the bottom of the screen, minus 32 pixels, which is the height of the player image. And then the image itself, pg.new, or image.new player. Okay, and the enemy is basically going to look very similar to this, so we'll copy that down to the enemy, random width, and then the height is going to actually be at the top of the screen and a little off of it. And then the image is going to be that enemy image that I dragged in previously. Okay, so that's our load function. Let's see, how am I doing on time? I don't think I'm going to be able to make this in 5 minutes, but I will cheat a little bit. How about that? The next function is playdate.update. If you used Love2D before, this is probably quite familiar. So in update, let's get rid of that. That's where the magic happens, because the update function runs every CPU tick. So first thing I'm going to do is copy and paste from my script, because I'm running out of time, I think. So I'm going to seed our random value every frame. And then I'm going to clear the screen every frame. And then the enemy, I want the enemy to drop down from its starting point constantly. So I'm just going to make it go down every frame. And if it goes off of the screen, I want it to just go back to the top of the screen. So I'll do that. And then if the enemy hits the player, I want stuff to happen. So super basic collision detection here. 2 rectangles colliding. That's what this function here does. It returns true if they're colliding and false if they're not. So I'm going to call that function for when the player hits the enemy. You can think of it in the opposite way too, when the enemy hits the player. I'm going to basically just draw some text. Game over at the center of the screen, and then I'm going to stop the logic. Okay, what about the player? We need the player to be able to move. So for this game, it's just going to be left and right. And I wanted to demonstrate player movement in a variety of ways here. So here's the D-pad. Playdate.button is pressed left or right. And for right it's +5, for left it's -5. If you wanted to, say, tilt the Playdate console to move the player, you can do this. So you get the accelerometer orientation, and then you just add that to the player's X value. And I'm multiplying it by 5 to just make the player movement a little more responsive to the accelerometer, more sensitive, if you will. And the last thing we need to do is, in the update function, is draw the player and the enemy onto the screen. We're doing all this logic, but we wouldn't be able to see them without these little commands here. Player.image, draw, enemy.image, draw. We just draw them at the positions we defined. And then I wanted to also demonstrate the crank. What if we wanted to move the player with the crank? That's a pretty simple callback function called playdate.cranked. It gets a value. The change value is basically kind of the same thing as the orientation of the accelerometer, except it's just a value in degrees of rotation. So I'm literally just adding that to the player's X position. This is everything we need for the game. Now, if I did everything right, the next step is to simply go to your command prompt and build the game with a simple command. First, I'm going to go to my game folder. Let's go here. And then it's PDC. PDC is the Playdate compiler, so we're just going to use that program. The source directory is where our game is, and then we're going to output a PDX file called mygame.pdx. Okay. Then we just open up the simulator again and open that PDX file. Let's see. I did not define enemy, so let me do that real quick. Oh, yeah. Oh, you know what? We need to call our load function. So that's what that is. Okay, then we run that command again. Let's try opening again. Okay, there we go. So now the objective of this game is to dodge the sad face, and if you don't, game over. That's my talk. Okay, so hopefully you saw how easy it is to make Playdate games. I really appreciate everyone participating. I think we have about 35 minutes for questions, if anyone has them in the Twitch chat or the YouTube chat or here on Discord.
Excellent talks, everyone. Thanks for sharing.
I agree. So I definitely have some comments and some questions for people, but I will yield the floor to anyone else who does.
I'm ready. Bring them on. Bring on your questions. Bring on your comments.
I've got a question for Glenn. I loved your talk. I was so happy to see that you were talking about Playdate, because I am the biggest Playdate fan ever. I cannot wait. I am in the first batch of people who will be getting them shipped sometime in the next 2 months, and I'm just so hyped. Do you have a physical one coming in?
I'll have it for Christmas, I think.
Nice.
I'm in the last batch.
Yeah.
And one thing I will mention about the Playdate, as cool and cute as it is, it's kind of expensive. So that might be the only downside to that console as far as I'm concerned. But it's really fun to make games for. As you saw, it's I think 50 lines of code made that little dodge the sad face game. And you can do a lot more stuff more complicated than that. So yeah, it's really exciting.
Yeah, I saw that the SDK came out, and I'm just waiting until I get my Playdate in the mail, and then I'll probably start using it, because I'll just, I
Yeah.
want to see it on the console as soon as I have it ready.
Yeah, I wanted to make a game for it, and so I'm glad the simulator works so nicely. So
yeah,
I'm glad you liked the talk. Hopefully you learned how to make a Playdate game.
Yeah, that was my first look at the SDK. All I knew was that it was out, but then from seeing what you're doing, it looks like it's going to be super familiar, like moving there from working with... I've messed around a little bit with Love 2D. It looks like it'll be pretty easy.
Well, Colt and I had a question about your talk. When you were talking about TTK, time to kill, and graphing that, one of the questions that popped into my head was, how might you use that metric to organize groups of enemies that the player might fight?
Hey, can you guys hear me?
Yeah.
Cool. I turned off my thing accidentally, but now it's on again. That's a good question. Let me pull up that slide again. You can see it for reference.
Do you use that metric to make groups of enemies, or?
Indirectly, I guess. I'm always kind of, I guess, yeah, this does kind of assume a single encounter. So yeah, the system would kind of need to be expanded, I suppose, in order to account for like a group of enemies. But that was one of those things that I made an artful exception for in Curse of Eternity. So rather than have, say, so in Curse, everything like power level is defined in a couple of ways, and like so this power level concept is split between a metric for how much attack power something has and a metric for what kind of each defense power something can have. Let's just assume it's one of them, say physical. And we have these weaker enemies called acolytes, and whereas like a normal enemy in the game would have like 20 attack power, 20 defense power at level 1, and then it increases each level. For the acolytes, what we did was we just underpowered them a little bit. Like maybe they have a quarter of the regular hit points of an enemy, so they can be usually one shot, because we want like 5 or 6 of them on the screen. And then they'll deal maybe like half the amount of damage or something. So in a lot of these cases where we want to make artistic exceptions to like have like a group of enemies that you can fight, that you can knock out easily and they don't hit you very hard, more often it feels like we're kind of cheesing it a little bit, but more often than not we just use a final multiplier on top of everything. Like the system underneath scales out to infinity, but when we want something to be different, like a boss fight or something like that, we just take the values and tweak them so that that particular encounter works the way we want. So if we want, like, if the nominal time to kill is 10 and we want a boss fight to last 2 minutes, that gives us some play area. So if it takes 10 seconds, we need it to last 2 minutes, assuming the player hits the whole time, multiply it by 12 or whatever the math came out to be there. Of course, we actually play test that kind of stuff and then go back and tweak the figures as necessary. But as a starting point, everything kind of is derived from a system much like the one you see on the screen.
Yeah, I really appreciated the math and the graphing that you showed off, and how to use that kind of math to design the progression systems in a game. Take that as broadly as you like. I think it's really important that people who are new to games are exposed to that. Sure, you don't need to use math, but it certainly helps on complex projects. And as you said, it enables artful design. So that's really cool.
Thanks, I appreciate it. Counter question. Where's the crank? What did we make the crank do again? I don't think I saw it used in your emulator.
Yeah, I was pressed for time, so I didn't get a decent chance to demonstrate that, but let me pull that up again, and I can share my screen again if everybody's cool with that.
When I first saw the system and you showed the website, I thought the crank was used for charging the battery.
Yeah, it's not a... it's a crank that's used for gameplay. So let me reset the game. I'm moving with the arrow keys now, but I can go down here, and this emulates the crank. Obviously, on the actual console, it would be a physical crank that you turn. And then here's the accelerometer, the tilt of Playdate console. So, yeah, that kind of demonstrates both or all three modes of interacting with the game. And I can use the arrow keys here to move the accelerometers. Anyway. So that's that.
Cool.
So.
I bet that will be fun once you get a device.
Yeah, I wanted to make the simplest possible game in the least amount of code I could, and that's what I came up with. So
I want to say I really enjoyed the puzzle talk. It's very succinct and broken down in a nice tangible way. I think that'll be really helpful to a lot of people wanting to get into it.
Thank you. I appreciate that. I really, really loved your talk. Economy in games is not something that like typically deal with in the kind of like specific like puzzle and strategy type games that I work with a lot. But I like the way that you think of cognitive load in games and using that like an economy. And I guess the metaphor for economy there is kind of a way to like practically illustrate how ways to create balance of a
Yeah.
certain thing in your game, and that's a really good way of putting it. I did have a question. I feel like in terms of how to find the right balance of cognitive load, in a lot of my games, especially like some of the recent ones where there are a lot of numbers and like there's basically a chart you have to study to play it. I feel like one of the things that I enjoy when I'm making games is pushing the boundaries of what the player's cognitive load is, expecting more out of the player. I find that to be exciting. But that sort of made me reflect on how that can be balanced to where that can decrease enjoyment. And so a balance is good, and having
Yeah.
systems that both drain and put it out
You
uh
can think of it
good.
like an accessibility option. Like if there are things you can do, if there are options you can put in your game that would help someone with a cognitive disability, then that's something to consider. Like it just sort of depends on your budget and who you're going for with your audience and stuff like that. But uh, people think of accessibility, they think of like colorblind support and like haptic support and stuff. But um, cognitive disabilities are a thing, and there are things you can do to mitigate them, if you so choose. It sort of just depends on what you're going for.
what games that you've played are some like bad offenders, as in maybe they have too much cognitive load, so to speak, and they're not doing anything to mitigate that?
Well, I think that, it's not always like they're doing something badly, but it might just be that, oh, sorry, it's a type of game I struggle with. Like for me, I can never get into 4X games, right? 4X games are just they're defined by the fact that they have high cognitive load. That's just
Yeah.
something I wouldn't be able to play. But I appreciate when games have like, for example, one example is like a character creator, right? Like, I'm not really the type of player who's motivated by the character creator, and I appreciate when character creators have lots of robust options and sliders and stuff. But for me, I was just like, okay, that's all great. Can you just give me something? Just like randomize the options. Just give me something to start working with because I can't handle that amount of choice. Um, and I'm trying to think of other things. Games where you can sort of like set up pre like deck building games where you're not even deck building games, but card games where you bring in decks are a nice way of mitigating cognitive load because you can set up your stuff beforehand when you're not under the time pressure of actually playing and just bring it in. So like I would like to see games do a similar thing with like loadouts, stuff like savable loadouts or, savable profiles, stuff like that. But some games just like I'm trying to think of an example of a game where I just couldn't play it because of that barrier, but I'm kind of good at recognizing them now, so I just don't. And some of them are like, again, it's not like they're doing anything bad, but I was playing a bunch of roguelikes this year because I played Inscription. I was like, I love this. This is like perfect for me. I need more games to scratch that itch. So I played a bunch of deck building roguelikes. And most of them I didn't get into because they had like a lot of details in their progression. Like Hades is an example. Hades is an excellent game. It definitely like hits its audience, but for me, there were too many vectors of like where I could do upgrades because like you did like certain upgrades in one way and some in another menu, and like it was sort of split apart. And I was like, I can't handle it. I can't do this. It's too much. So that's just sort of examples of what that can look like.
All right. And Alex, when I heard that Godot uses scene graphs as their sort of design paradigm, I actually got scared away from Godot because I've tried to get into that sort of, I guess, mode of thinking about how to put a game together, and it's not traditional. How did you, I guess, approach it? Had you used scene graphs and stuff before Godot?
Well, so before Godot, I did a lot of stuff in Unity, which uses both scenes and prefabs. And as I got like more deeper into Unity, I kind of like had started having more difficulty with that system. And Godot was kind of like an answer to a lot of the troubles I had with Unity. So I think it's like a combination of I'm used to working with that type of paradigm, that sort of, scenes and prefabs, working with things like that. But then also like having Godot introduce just kind of like structuring the whole game as this tree of nodes and having it, it making sense to me.
I delved into that kind of paradigm with an engine called Amulet, which is a Lua-based framework, and I saw the potential for very quick iteration and kind of making simple, complex things. But I didn't get into it well enough to really overcome my fear of that paradigm. I prefer, I guess, functional programming and lazy OOP. So. Okay. Do we have any questions from the Twitch or YouTube stream, Alan? Yep. Okay, well, I guess we can call it a day there. Again, I really appreciate everyone's talks. I think they were very informative, and it's these kinds of knowledge sharing events that really enrich our community. So if you're on mute, give yourself a round of applause.
Yeah, I appreciate it a lot. These were really fun. When will this be words? Hang on, let me try that again. Will this be posted on the YouTube channel and when? Oh, right, that's because you were streaming, right? Huzzah! Cool.
Yeah.
Cool.
Also, I shared my slides in the chat. I posted a link right under Colton's slides.
I was gonna ask about that. I really love those slides. So, and I've been struggling to get into puzzle game development, so I might actually take a look at your framework.
I would also look. It's based on the framework from Game Maker's Toolkit. Did a really good video breaking down. The assumption twist revelation comes straight from that video. So I
Cool.
definitely recommend that one as well.
All right. Thanks, everyone, and have a good evening.
Thank you.
Good job, guys.
Thanks, everyone. Bye.
Hi, everyone.
Yeah.